All right, so now that we have this OR gate that works, and I'll plug it in again so that we can just verify that. Where's my other wire right here? Negative goes into the negative. So one input works, other input works, and both of them work together. So now that this works, I need to turn it into an OR gate, which is the inverse. So right now, with both inputs off, or 0 or false or low, however you want to call it, the output, if this is our output, which is also a bit confusing to me, but let's just call this our output. Output is off right now. So with a not OR gate, it should be on. And then when we click one, it should turn off, because in this case, it turns on, right? So we're looking to make a logic gate that's the opposite of this one. So it should be on now, then it should turn off. It should be on now, it should turn off. It should be on now, and it should turn off. I don't really know how to do that, so I think what I'm going to do is try to make a NOT gate first to kind of understand how that works, then try and put them together somehow. So I think a NOT gate is kind of simple. Dare I say that? And the reason I say that, I have a new breadboard here. So the other one is still there. Our OR gate is still there. Because we should be able to use both of them, I think. So we know that a NOT gate with both inputs off should be a 1. Both inputs off should be a 1. So what that means to me is we basically have an LED that if the LED is the output, that is turned on by default. So I'm going to, oh look, I knew I had one of these that's cut. I don't know what that is. Maybe it's 100K. I mean 100. I'm gonna take out another 1K. I don't know what that guy is. He might, I don't know what he is, so I don't want to test him right now. So I'm gonna use a resistor. This is another 1K from the little pile that I had. Man, I do need to start cutting them though, because this is getting a little lame-o. Yeah, I took him out of here. So we have a 1K, and then we have a light. So I'll put the long end. Long end is positive, so I'll put the long end to take the input that the resistor is sending, and then now we just need to ground this, which I have a little wire here. I don't know if this guy is long enough. Let's see. Maybe. Oh, he left. Okay. Well, he doesn't want to play. I have a gray one. Maybe that gray one will work. Gray looks like he wants to work. Yeah, I think this. Okay, cool. So we have power coming from the positive through the resistor to bring it down to a current that is good for our LED. It's going to go into the LED and out to ground. Very basic circuit, kind of like the first one that I did. So if we connect our power, positivo, and a negativo, so our light turns on. And this is the state that a NOT OR gate, let me raise that camera a bit. The NOT OR gate should be on, right? With no inputs, it should be on. So now we need to be able to turn it off with a switch. And that's the part that is kind of interesting. So how do we turn this off? It's like we want to divert the power or cut the power with a switch. Uh, so I don't really know what that means. We have the power coming from the LED or from the resistor to the LED, and we want it to not go to the LED with a switch. But if I add a switch between them, then it will just turn into a switchable LED. We want it to be flipped. Well, I'm gonna just start. I'm pretty sure we need to connect something in parallel, right? I mean, anything in a series is just gonna be off until we make contact. There's a little ant on me. I don't really know. Might need to look up some assistance. Let's see. Let's spread this out a bit. So we have our LED, and I think it has to be in parallel, right? Because I don't know if it really works that way, but it's almost like we want it to choose to go this way when there's nothing else available. So if we provide another path, then maybe that's the way to do it. So like, for example, let's say, that hurts. I just pricked myself, I think. If we give this guy another path, right, we just make a simple circuit, what happens? Alright, let's plug in power. Is power on? I think power's on. So, let me see. Okay, no, power. I don't know what's happening right here. Oh, wait, the LED is not grounded. So, down. I don't even know what I'm doing here. I think I need to look this up. Let's see. If we add a long cable, well, first of all, is there current right now? I don't even know. I know that, yeah, there should be. Well, there should be because we're plugged in and the LED does have path to ground. So, let me add another path to ground over here so that the LED can get to it. This is not a good looking circuit at all. It looks terrible. Looking for another cable. All right. So right now, I think the LED is plugged in. This guy's in very tight. Get out. All right, so something is happening here. But I don't know exactly what. So it's on now, but then when we plug in another dude, I think the logic here is good. I'm missing something, I think. So if we plug this in again, then the light turns off. So if this was a transistor, maybe that would work. Uh, I don't know. I think I should look it up. Yeah, let's look up a schematic. I feel like this is close, or maybe it's it. I don't know. I don't know because I'm just not seeing how I would use it, I guess. But maybe I'm getting ahead of myself. So we know the power's on right now, and I guess the input is off. We could say, right? It's plugged out, kind of. I don't know. No, I don't think it makes sense. Anyway, I'm gonna look it up. Let me see.
All right, my computer got reset, I think. So I don't have my previous tabs, but I don't need them, I guess. So let us search for uh, inverter, I guess. Inverter gate. And I don't know what I'm looking at. This looks like something, but man, this looks confusing. What is that? So, I guess positive? I don't know what this is. Man, maybe it will be complicated. Here's a picture, and there's a lot of wires here. 5 volts. RC, what is that? Resistor? I was just hoping for a schematic that I can understand, but maybe that's being a little ambitious. I don't know. Okay, this has more labels that I like. So here's ground, and here's 5 volts. What is this thing? This is the LED. This is our switch. Okay, I like how this looks. Do they have like a legend? So I'm gonna put, what is this? A schematic, right? I think it's called schematics. So schematic legend. Yeah, that looks like. I should probably print this. I'm looking for that, like triangular. What do we call this? Like a stick figure almost, like a, it's like a giraffe or somebody bending over. Um, the bending man sounds like a horror character. I'm gonna print. All right, which one do I print? I still haven't found that, so I'm looking for that symbol. Man, that is a lot of stuff right there. Let's see, symbol, 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 symbol. Okay, a squiggly line we have. I think yeah. Well, this one seems, it says 2K. So yeah, this is a resistor. I like that, and a resistor. Ground, 5 volts. Ground, 2 grounds. Uh, does that suggest parallel? I guess that means it's parallel. Um, but where's our other symbol? A symbol, as Batman says. I can be more. I need more. Dude. Maybe I'm not looking at the symbol right. Maybe it's not a bending man. Let me look at this one properly. I guess I'm not focusing. Ooh. That looks like similar, right? There's like 3 and oh, it's a transistor. E B C. Yeah. Okay. At PNP. Perfect. Okay. So wait, no, but where's the bending man? What? Where's the bending man? Or is this something else? Damn it. I need to learn about this stuff. What are the dots? Because some of them are filled in and some are not. What do dots mean? Schematic. A dot represents a connection point between, okay, or that's simple. So these connect, these connect. These connect. But these are empty. I guess because the switch is off. I guess the switch is off. So it's just this thing. So it's really not a bending man. It's a wire connecting to this. So I'm gonna print, okay, I'm gonna print this one for sure. And I'm gonna print the legend. Yeah, I'm gonna do that. All right, cool.
All right, so now that we have our papers, should be able to read this and make it back on our circuit. So that's the goal, is to understand this schematic. And I have seen these before very briefly, but I don't really know how to read it. So I need to do that now, and I have this legend that I found, or that we found, I should say, and we can, hopefully make this work. So right off the bat, I do see the 5 volts source. So positive, negative, and I have positive, negative, right? So positive, negative right here, and this is a ground. Everything connected here is ground. And this is another ground. So it's a little bit confusing. So positive, we have a resistor, right? Resistor looks like this. So we have a resistor connected. And then we have a switch. And then this is a I assume T means transistor because it says PNP and EBC. So I don't know enough to know what all this means, but I know that it's a PNP resistor. Sorry, it's an NPN. Sorry, NPN resistor is what I have. And I don't know what that means. And MOSFETs, I've used some MOSFETs in some machinery to control motors, but I've never used it. I've never really done circuitry or stuff. So let's try and make this. Maybe I could follow it along as I understand it, because it is a bit confusing to me. At least to me on these circuits, it's very clear when we have a ground signal. But here, it just seems like, at what point does the positive become the negative? It's probably a silly question. But all right, so let's see. So we have our positive voltage and we have our resistor. So this has positive and it has a resistor. So we've done that. Then we have a switch. And the switch goes to, I guess, a base. This must be the base. Yeah, because the base on this one, it says the base is alone. And then we have, so it's EBC. They're just flipping it so that we can set, I guess you can more easily draw what's happening. So this, I like this, the EBC, that makes sense to me. So that means it's EBC. What? I guess so, actually, yeah, because this is connected in parallel. Oh, I think I see what's happening here. Yeah. So the power comes in and goes to the LED and goes to ground. The power would like to go this way, but it won't work unless this is powered up, enabling this to go through. Yeah, that's what's happening here. I'm assuming. Yeah, this makes a lot of sense to me now, after looking at it for a bit. So, the circuit comes in, and we can't make a circuit here for it to go to ground, because this switch is not connected. It's open. There's a 0 here. This is a 0 signal. So since the base is off, the collector cannot emit. I noticed the arrow now, so clearly this is the emitter. So this guy, the collector wants to go home, but he can't without this guy being on. So in that case, the power just won't flow here, but there is another ground access, so it can flow that way, lighting up the LED. This makes a lot of sense. And then so this LED, when this switches off, we can say, when there's no power on the base, right? The base is not activated, that the collector is not connected to the emitter. There's a traffic jam right here. So when the power comes this way, he gets stuck, but he does find another way home through the LED. So this is on when this is off. And when this is on or connected, then this is off, because now the electricity can flow this way. And I'm assuming it's the resistance of the LED that will sort of allow this to be possible. The transistor's resistance must be very low, and we can check that with the meter, but I'm going to try and make this first. So this is quite simple. Now that I see that, I guess for me the problem was like seeing the direction of where it's going, since there's 2 grounds, which is kind of weird, but I think that works. So let's see. And also, I don't understand if there's a negative here, like ground. I don't really, because this guy should connect back over here, but maybe it's just assumed that happens, and maybe they put it over here to make it clear. I don't know. Or this is a load, or not the load. This is more circuitry. Yeah, so this could be an output. As long as it eventually reaches ground, we can do more stuff here, I assume. Anyway, one thing at a time. So I'm gonna plug out all this, even though the power's not connected. These are just disconnected wires, but I'm gonna start fresh, I think. So I have, let me get a button. Button right here. A little button. There's one. And then let's get a transistor. This uses 1 transistor. And let's make it work. All right, so we need another resistor. I'm excited to try this. We need another resistor, another 1K. So we take him from his family. Whee! And I think at this point I probably should start trimming them, because it is very annoying to deal with all these cables. So I'm just going to trim it off. Okay. And then all these little extra sticks that I get, I'm going to put in a container, because which container should I use? I don't know if I'm going to need them later. Probably not. I have a few of them laying around, but you never know. All right, so I'm going to put them in this little container. And that's one. I'm going to plug out this guy, and I'll cut this guy too. And at least to make it more manageable. Put those guys in. So we have 2 of these. Let me make some more space here. All right. So on this schematic, there's 2 things connected to the positive, it seems. There's one going to the resistor, and there's another one here. So 2 circuits. So I'm gonna replicate that. Let me take out my green cables. I'm gonna replicate that and see if we can make that work. So here's one. So I'm gonna kind of put it arbitrarily on number 5. Oh yeah, much cleaner. Look at that. That's beautiful. Whee! No more giant spiders. Well, not for now. The other one has many spiders on them. And I'm going to plug in the second one further down the line. I don't know where is best yet, but got a jumper. I'm gonna just try and straighten these out a bit because these are a little bendy. All right, so I'm gonna put this guy in maybe 10. I don't know if it's easier with these tweezers or harder. I don't know if I'm making it harder on myself. Number 10 goes in. Oh my goodness. He fell on the floor. All right. Hands it is. Just can't replace the dexterity of hands. Perfect. All right. Tweezers, you are fired. You sad now. So we have 2 resistors in. For these, let me get this on the screen. So we have 2 resistors in for these 2 inputs, right? Positive, resistor 1, resistor 2. These are 2Ks, but I'm just going to use my 1Ks. It's also 5 volts, but I'm going to use my 3 volts. And now we need a switch on the first circuit. Ooh. No, I'm not doing this properly. This is parallel coming off, but this is series. Right? Damn, this is kind of confusing. Because if this power needs to choose one of these, that would mean it's... No, series is wrong. I don't know what this is. All right, let's make one of them. Let's just make one of them and then add the other one. Maybe it will probably become clearer to me when I restart. All right, so we have our resistor and then we're going to have a switch. So here's our switch. There we go. Oh, he does work. Oh no. Bloop. These switches are not very in there. I like clicking it. Sounds nice. Feels nice. All right, so switch, and then we go to our base. All right, so I'm gonna use some extra space here to make it clear what's happening. So I'm gonna get a little wire, un poco little wire ito, and send him down. So we're gonna send him down. Downtown. If he'll go in, man, I am not good at putting these in at all, dude. Wow. All right, this guy's a little bent up, so I'm gonna do a different one. All right. A 1, a 2. Dude, how is this so difficult? Button, come back. Damn. What a mess. All right. Oh no, man, this guy. Okay. Maybe the other one's better. Dudes, what is up? I have the slide switches. Maybe I should do that. Man, what the heck? Maybe I'm not doing this right. Okay. Maybe the slide switches are better. I do have these slide switches. Although, okay. So this is off. That means I need to move this now. Okay. All right. So this is a slide switch. So this is on, this is off. And the reason why is because I have 3 pins. So the middle pin is, I think, what you'd call common. And then you can send it this way, which means these 2 pins are now connected. Or we can send it this way, which means these 2 pins are now connected. So we're drawing from the center and either sending it here or here. And in this case, if it's like this and there's nothing connected here, then it's effectively off, right? So I'll use that guy. He seems more stable than the other one. And now that we have this guy being sent down, now we can put this into our base. So remember, flat side facing us, and then EBC. So it's into the base, which activates the base. So now, looking at our little schematic again, so we have our switch going into our base. The collector is powered. Oh, I see. This is only powering the switch. This is going to power the actual LED and the collector. Okay, so I think how I had it was right. So the collector is on row 8. So I'm going to put this on 8. Right? Bloop. Yeah. Okay, it's making more sense now again. So we have one resistor only powering the switch, which will power the base whenever it's activated. And then we have the collector powering, sorry, a resistor powering the actual collector directly. So the collector is getting power directly and the switch is getting power directly. Now, this is a parallel connection because it can go either way, right? So this is parallel. So now that means the LED must also take power from, you know what? First, let's finish the transistor. So we have our collector receiving power, switch receiving power, switch goes to our base, collector wants to send to the emitter, and the emitter must go to ground. So let's add our ground connection for the emitter, which is 10. I kind of like how this is laying out because everything is nice and close. But that's only because I'm following a schematic. So somebody who knows what they're doing did this. And I'm going to do... Some of these are just so small, though. I don't know if I can do it with my hands. So 10. Oh dear. Gray wire? Gray. Okay. 10. Okay. Perfect. So our emitter goes home to ground. Now, let me just zoom in a bit. Straighten that up. So now, the LED must also connect to this point, which I guess just means like the row that we're on. So that's row 8. The same point that the collector connects to, the LED must also connect to. So if I get my LED and get the long little legs for positive, right? This is a long one. This guy can connect, let's say, to 12, and then I also have to ground that separately. So I guess that's it. So let's add the ground to 12. Okay. So the switch has power. The collector has power. The base will only receive power if the switch is on, which will allow the current through the collector and to go to ground. when the switch is not turned on, the collector won't be able to go through to the emitter, so that the power will be forced to go through the LED and go to ground. I think I understand, and I think it will work. It's kind of cool. So I'm gonna plug in. Let me zoom out real quick. Uh-oh, I think I zoomed out too much. So let's see. So we have power. No. 1 and 2. All right. So we have light. That's a good sign. So right now we're off. We're in the off state, but the light is on. Hey, that's cool. And now we turn on the switch and the light turns off. I think this is working. Right? Off, but the light's on. On, but the light is off. So this schematic was really, really good. This guy, I don't know, he wants to be on camera or something. Yeah, this is really good, and it's quite clear once I understood that this means it's parallel between these two, which makes sense. This point is connected to two things. This point is just pulling off of, so this is in parallel from the power line. It's a little confusing, but hopefully with practice, it will become more easy or easier, let's use proper English, to read them. So this is really cool. This is the inverter then. And now the question is how, wait, I plugged out the wrong side. How do we make this, the OR gate, how do we use the OR gate with the inverter? How do we, first of all, how do we output from here to use as an input for here, right? So we have our input. We can put anything we want into this, into the base. Any signal we want can be used as an input for the base, which will be flipped by the inverter. So the question is, my output, I don't even know my output is here. I'm using the LED to indicate the state of the circuit, but it's not truly an output, in my opinion, because it's not like I can replace this with other logic using this as input for that logic. I don't know if it works that way, man. So much to learn, like little things like this, because something just doesn't seem clear to me. But I think I'm gonna take a quick break and move on, try and figure this out. But it's great that the inverter is working, because now, now that I think about it, the inverter itself is kind of an OR gate. It's already kind of a not OR gate almost, because we could add more switches together and only one of them has to be on for the light to turn off, right? So maybe there's something to it, to that. Well, maybe because I use a schematic and I did this one myself. Maybe I should look up the schematics for the other gates instead of trying to figure it out, because this ended up really simplifying it. So let me see. I might try and do it myself, or I might look it up. Let's see what happens. Yeah, so I think that instead of looking it up right away, I'm going to try and do it. But I thought about it a bit more when I paused the video. Hey, look, there's an ant on the LED. You want to see a light, dude? Maybe he wants it to light up. I'm going to plug this guy in. And plug this one in. Behold, ant. Behold, light. Da da da. You think you got excited? Bloop. All right. Anyway, so what I was thinking, let me turn this off, is that funnily enough, it's easier for me to envision this being a not OR gate than this one becoming a not OR gate. And I'm going to try and do it real quick because I feel like, well, I'm not even going to worry about the logic yet. I'm just going to add some more switches to this and connect them together because I feel like this is easier to turn into it. I don't know. Maybe I'm crazy. Or I shouldn't call myself that, but maybe I'm just, I don't know what the right word is, but confident without knowledge. So I'm going to take out this switch. Although really, if I just add another switch, then that should do it. I think it's as simple as that. If I just add another switch, then I feel like, because all these are already connected, right? All the rows are connected. So let me plug this in and see if that works, because I have a feeling it will work the way I'm thinking. So positive, negative. Okay. So right now both switches are off. Both switches are off. So NOR should be on, okay? But as we can see, anytime any input is on, NOR turns off. NOR is only on when both are off. And I'm pretty sure this will work that way, right? Yeah. So this is an OR gate, funny enough. It's the same as the inverter. Isn't that funny? Both on, the light is off, right? I know it's probably kind of hard to see, so I apologize. But so both on, and we have an off signal. Both on, off signal. Both off, on signal, right? Both off, on signal. And then, of course, individually, they create an off signal. So, again, what I like about this setup is that, and the schematic, I think, is really what helped me a lot. This output, the LED could be anything, right? This is just showing, I think, that this could go on and do all sorts of other evaluations, but the point is that the output is at the end of the circuit, free to go to other places. Whereas in my OR gate, my indicator, I don't even want to call it output because it's not output, but my indicator is in the middle of the circuit, and good luck sending this somewhere else. Now I guess we could say that one of these could be used as the output as long as it reaches ground eventually. I guess that's the case, but I guess since the LED is here, it's more obvious to me. Maybe that's what it is. But this is an OR gate, right? I think it's an OR gate. So that was very unexpected. Instead of flipping this to become this, I used the NOT gate and just added one little piece and it became a NOR gate. So these could be separate inputs. These could be inputs from anywhere that go into the base. And when any one of them are on, it will turn off. Like in this case, they're both on. So this is off and off. So it turns on. That's pretty cool, pretty great. A lot simpler than I was thinking. So this is great. And again, I really can't highlight enough how clear it is to me, at least as a beginner, that this could be used as an output. This cable, right? This gray cable going out, it could go on to all sorts of other stuff and act as an input for those future evaluations. So no flipping of this. We can flip, actually, Well, now I'm thinking if I replicate this over here, I could actually turn this into an OR gate, since I can output. Does that work? If I can output the LED into another transistor, then I can invert this, right? Damn. Sometimes I don't know if what I'm saying makes sense. This one still works. This is an OR gate. Now, if I do try and make this into an OR gate, which is what I'm thinking right now, I don't know. It's going to be a lot more complicated than this one. Although this one already has 2 transistors, and this only has 1 transistor. I'm going to try and see if I can basically add another inverter, so I can invert this signal. Since I have 2 inputs now, I can invert this and make it hopefully into an OR gate. That's my goal now. I want to make another OR gate, but using this method where the indicator is at the end, so that it can be used as an output, because I don't know how to make an output out of here. Or, well, maybe this can be used as an output. Maybe what I should try real quick is, yeah, I don't know why I'm skipping that. I should try and make this into an output. So I'm gonna plug in a green LED to act as output, and I'm just gonna move this wire. Let's see what happens. So if I press a button and nothing happens, why not? Damn it. Nothing happens. Pretty sure my power's on. Alright, let me plug this guy out. I'm getting so dangerous doing this with the power plugged in. I guess that's what happens when you get familiar and then you end up electrocuting yourself. Alright, so this goes in. Get in there, guy. Get in there. Okay. Yeah, so it's, what the heck? So it can't be used as an output? So it works this way. Boop, 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 boop. Oh no, button. I don't know. All right. Let me try. I have heard that the different LED colors take different power, so I'm gonna use this other one. This is red. This goes here. And let's move Mr. Greyman over just a wee bit. Okay. Hey, that works now. But this guy does not work. Why? I have no idea. Oh. Ah, buttons. They're revolting, dude. So that does work as an output. Okay. Yeah, that works. So I don't know what I was thinking then. I guess it's time to move on to an AND gate. So cool. All right, so I have an OR gate where I can use the output. I could just send this wherever. This one doesn't work anymore for some reason. I'm not quite sure why. I don't need it because this is now my output and it's at the end of the circuit, which I like, so I can send that down. So, all right, I'm gonna move on to an AND gate, and then eventually we'll see what we can make with these different gates. I just want to make each gate and then go from there.